In this video, all students will be able to state the domain and range of a graph. Domain and range are huge topics in Math 1 that we will review throughout the year. Domain refers to the set of x values, or independent values, of a graph. Range refers to the set of y values, or dependent values, of a graph. Domain always refers to x, and range always refers to y. So before we continue, we need to do a little exercise to help us remember that. When I say domain, you say x. Domain, domain, domain. Now when I say range, you say y. Range, range, range. Now I'm going to mix it up. Same thing though. If I say domain, you say x. If I say range, you say y. All right, you ready? Domain, domain, range, range, domain, range, domain, domain, range, 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 domain. Good job. Specifically, the domain and range describe restrictions or limitations on a graph. We describe restrictions on the x values within the domain, and we describe the restrictions on the y values in the range. So take a look at example number 1. We need to go ahead and determine the domain and range of each graph. Remember, domain refers to the x values and range refers to the y values. So we're going to take a look first at the domain, and we're going to take a look at the x values in particular. So taking a look at the x values, you'll notice that this graph has x values on the negative side and x values on the positive side. And this graph goes on off the graph on both directions. So in this case, this graph has a domain that includes all real numbers, meaning all numbers are possible. Let's go ahead now and take a look at the range, which refers to the y. If I take a look at the y-axis, I have values up here, but I don't have any values down here. So what that means is that the graph is only occurring on this part of the y-axis. So for the range, y is always greater than, right, because the positives are up here, greater than or equal to, what's the minimum? The minimum is way down here. What's that? That number is 0. So in this graph, the domain includes all real numbers, and the range has to be y is greater than or equal to 0. Let's take a look now at example number 2. On example number 2, we have actually a linear equation, which we could probably write the slope-intercept form for it if we wanted to. It goes off the graph on the right side, and it goes off the graph on the left side. Remember, domain refers to the x's, and range refers to the y's. So we're going to first look at the domain, which means we need to look at the x-axis. I can see that the graph exists over here because it's going up and off the graph. That means positive numbers work. It crosses here at 0, and it's over here on the negatives as well, right? So if you plug in like this -5, you get a value way down here. So again, the domain of this graph is all real numbers. Let's go ahead and take a look at the range. The range includes the y's. Well, the y's, if I look at the y-axis, I have all these numbers on the positive y's. And if I look on the negative side, I have all these values down here on the negative side. So the range for this one also is all real numbers. There's actually no restrictions on this graph whatsoever. Go ahead and pause this video now if you need to get caught up. Okay, now we're going to get into some trickier examples. Okay, in this first graph, we have a curved line, and we need to look at the domain, or the x values, and the range, which are the y values. This graph starts here at this point, and for the x's, only goes towards these numbers, which are positives. That means the domain has to have x is greater than or equal to, what is this smallest number right out here? This is 0. So for the domain, x's must be greater than or equal to 0. Now what about the range? What about the y values? Well, I see it starts here at 0 and then it goes up. It never comes down here where the negatives are. So for the range, y's have to be greater than or equal to 0. Go ahead and pause this video if you need to fill in example number 3. Example number 4 is a little bit different. For example number 4, again, let's take a look at the x's for the domain x. I see that the graph only exists on this half of the x-axis. There's no graph that exists on this side. So x starts right here and it goes farther into the positive. So x has to be greater than or equal to 0. Now for the y's, which is this axis right here, what is the smallest value for the y's? What is the smallest value? I'm just going to clear this out so we can see it a little bit better. I drew all over it. This number right here is -4. It actually starts at -4, and then in terms of the y value, it's going up from there. So y has to be greater than or equal to -4. Number 5, before we begin, I just want to clarify one thing. This graph goes forever off the graph right here, but there's actually a dot here that didn't really translate very well onto my screen. Okay, so it actually stops right there. So in terms of the domain, if we look at x, remember our domain is x, for the x-axis, it doesn't actually continue right there. It actually, the greatest number is a 5, and the graph has x's that go off to the left. So x must be less than or equal to 5, because it only has all of these x's involved. Let's go ahead and take a look at the range, which are the y's. It starts way up here, which is what number? What number is that? That number is a 9. And then for the y-axis, it actually is coming down, right? So for y, it has to be less than or equal to 9. Now this is a pretty tricky concept, so what I want you to do is pause, get caught up, and then I want you to try 6, 7, and 8. Pause this video, and I want you to try 6, 7, and 8. Then we're going to go ahead and review, and I'll give some explanations, and you can try your gate check. So taking a look, we see the answers for numbers 6, 7, and 8. On number 6, x has to be greater than or equal to x, right? Because the graph only occurs on this side for the x-axis. But y has to be less than or equal to 0. It only occurs down here for the y-axis. For number 7, the domain is all real numbers, so we see some graph on the positive side as well as on the negative side. But for the range, since it's only occurring down here, that means that for the range, the y's is at maximum 0, but it should be less than or equal to 0. On number 8, there actually are no restrictions. The domain is all real numbers. We have positives and negatives. And the range, which are the y's, I have positives and negatives. Okay, I know this is a tricky concept. That's why we're introducing it early, and we're going to review it many times. Thanks so much, Honey Bunnies.